Today we will be talking about Laplace transforms. Now this is a very interesting concept in engineering, especially when I first learned about it. Right, so basically the idea of it is going to be taking a differential equation, right, and turning it into an algebraic problem. Now this is really cool because it becomes so much easier to solve, not only for us, but for computers as well. And you'll see that Matlab actually has a function that can basically solve differential equations using Laplace transforms. Really, really cool. Now, what do they do, right? What does this differential equation even mean in the real world? Well, basically, what this models is some force input, right? Some input into our system, and the modeled response of that input given some initial conditions, right? So there's so many moving parts of the system, yet this differential equation can capture, all of those moving parts and the effects that they have on the system as a whole, right? Super useful in circuits, in robotics, in control systems. And so without further ado, let's go ahead and get started with number 2. So number 2, as you can see, we basically want to turn each one of these components, right, into the Laplace domain. Okay, so we're going to take x double dot, and we can see right here, x double dot is equal to s squared, x of s, minus s, x of 0, minus x dot of 0. Okay, so we see some initial conditions popping up in there. Now next is the 14x dot, right? X dot is equal to this, so we're going to go ahead and plug it in. Right. By the way, you can find this right side table just on Google if you search up Laplace transform table. Right, so this is not gate kept information or anything like that. Okay, so our second piece done. Now, lastly, we have the 49x. Now, x is the easiest. X simply just turns into x of s. Okay, not too bad. Now, next is going to be the 5 unit step function of t. Okay, US stands for unit step function. Right, so if we look over here, the unit step function is 1 over s. And so this right side will be 5 over s. Okay, that'll be, again, our input into the system. And this will be contributed to the forced response. Okay, the forced response of our system will be from the right side of the equation, in this case, the unit step function, right? And so we're going to have to keep track of this guy in order to figure out the free and forced response. And the free, in fact, depends on the initial conditions. Okay, so 2 characteristics of the free and forced, and together they create the complete response. Right, so next we want to solve for x of s by itself. We want to isolate x of s. Right, we see so many x of s's in this equation. We see one here, we see one here, right, and then we see another one here. So we're going to want to isolate that. And the way we're going to do that is basically by factoring out x of s. Now, I wrote this in multiple lines, but basically these are all added to one another, right? This is all addition happening between all of these, as we can see in the problem. And so essentially what I'm going to do is factor out x of s. Now the first term we're factoring out x of s from is this s squared term, so the s squared is left behind. Right, the next one is going to be this 14s term. And lastly, we're going to have the 49, right? So we factored out x of s from all of those. Next, we have all the leftover components. We have this sx of 0, negative x dot of 0, this negative x of 0, but make sure we're distributing this 14 in, right? And I don't think we have any other distribution happening, so that's the only one we have to really watch out for. I'm going to write that on the second line. So we're going to do negative s x of 0. In fact, I'll go ahead and plug in x of 0. X of 0 is equal to negative 1. So I'll go ahead and plug that in. Negative x dot of 0 is negative 3. So minus negative 3. Okay, and then lastly, minus 14, right, because I distributed the 14, minus 14 x of 0, and x of 0 is negative 1. Okay, and this will all be equal to 5 over s. This is great. Our equation's getting shorter. Okay, that's the ideal scenario. So now I can go ahead and do a little bit of simplification. This will become a plus s, become a plus 3, and this will become a plus 14. Okay, so these two terms combined, we get s plus 17. Okay, so let's move on. X of s, okay, we have some stuff in the parentheses there. Now I want to shift this guy over. So we simplified all of this down. this on one line. Just might need to resize this a little bit. Okay. So now we're here. We have x of s by itself, and we have these other two components. So we need to move those over to the right-hand side of the equation. So we're going to go ahead and subtract, right, s plus 17. Okay. And I'm going to keep these guys separate because this is going to be my forced response and this is going to be my free response. So I'm going to keep them separate. Okay. It also tends to make the problem easier to keep it separate. So if you need an incentive to y, then there's your reason. S squared plus 14s plus 49. And we're basically going to divide both sides, right, by s squared plus 14s plus 49. So x of s will be equal to 5s s squared plus 14s plus 49, okay, minus s plus 17, s squared plus 14s plus 49. Okay. I'm just going to move this up here since we're going to need a lot of space. We're going to have to do what's called partial fraction decomposition. Hopefully that rings some bells in your head. Okay. So next we want to see, this is a quadratic equation, right? ax squared plus bx plus c, right? Except x is now s. So we can actually factor this. Now, if you need a review on factoring, you can go watch some organic chemistry tutor videos, just like how I did back in high school. Or maybe by now, who knows? Maybe I'll have my own algebra review, videos up out there. But for now, we're going to factor this. And in fact, we don't even need two parentheses because this is going to be s plus 7 squared. Right? So s plus 7 squared. So let's simplify down a little bit more. 5 over s plus 7 squared, okay, minus s plus 17, and s plus 7 squared is bottom here. Okay. All right. So we want to do partial fraction decomposition. And because we have two different fractions, we're going to need to do two partial fraction decompositions. Okay, sounds like a lot. Kind of is. It's a little tedious, but hey, that's the price you pay when you don't have to do calculus. Now, let's work on this section. So I'll go ahead and split this down the middle. We'll work on this left side first. So the form is going to be a over s plus b over s plus 7 plus c over s plus 7 s plus, thank you, s plus 7 squared. Okay. Now we're going to do, we have to multiply all of these guys. You can think about it as like we need to add these back up so that we get the original equation, right? We need to add them back up to get the original equation. And in order to do that, they have to have the same denominator. So for the a over s term, we're going to multiply it top and bottom by s plus 7 squared. Right? Again, this is partial fraction decomposition. So if you need a review with this, again, organic chemistry tutor, it's a great resource. Now, a is going to be times as squared plus 14as plus 49a. Okay. Next is going to be b. We're going to have b s squared plus 7bs. Okay. And I think I'm lining everything up. I'll do a 0 here to keep track. And then lastly, we're going to have c. And we're only going to have a cs. Okay. There's going to be no other terms. So now, these must all add up, right? So let's look at this column. Okay, we have an a plus b, and those correlate to the s squared term. But we can see in the top, we only have a constant. We have no s squared term, so a plus b has to equal 0, right? Because we don't have an s squared term. We don't want one in our original equation. We don't have one, right? So next, look at this column. Right, we have 14a, so we have 14a plus 7b plus c, and that will be equal to, again, 0, right? Because we don't have any s term in our numerator. And the last one is going to be this 49a, right? 49a is equal to 5, okay? Because 5 is the only constant term, and all of this column is the constant terms, right? Except luckily for us, these are both 0. And so we can actually solve for a already. A is equal to 5 over 49. Now, feel free to also do this using a matrice, right? If you're If you're a little savvy with math or your graphing calculator, you can actually put this into a matrix and have it solve for all three variables. Since this isn't too crazy of a matrix, it's just a 3x3 and it's not super hard, I'll go ahead and do it by hand. But if you feel savvy enough and don't need to show the work, then go ahead and skip this part. All right. So a is equal to 5 over 49. So that's our first step. Next, we have to solve for b. So we're going to go ahead and use this equation to solve for b. Now, if a is equal to 5 over 49, then b must equal, right? B must equal negative 5 over 49 so that they cancel out. Okay, that's our next term solved for. And now that we have two terms solved for, we can use this middle equation, right? We use this middle equation to solve for c. So 14, 5, 49, plus 7, negative 5, 49. And then plus c. It's equal to 0. So we're going to get 70 over 49 minus 35 over 49. That's going to get us 35 over 49. Okay. We have plus c is equal to 0. And so c is equal to negative 35 over 49. We can simplify this down, negative 5 over 7. So in other words, c is equal to negative 5 over 7. Okay. So let's go ahead and write this all as our decomposed fraction expression, right? So now I can write this in the form that I wrote up here. Go ahead and do it. 5 over 49. And I'm going to write the fraction outside, and I'll write it like 1 of s. And we'll see why, right? If you look at this table, you see that everything is in the form of 1 over s, 1 over s plus a, and 1 over s plus a to some degree power, right? So I'm going to go ahead and make it easier for myself. I already write it in this form, so I don't have to do too much, rewriting of my equation. Now b over s plus 7, b is negative 5 over 49, so I'm going to do negative 5, 49, write 1 over s plus 7, okay, plus c, minus c. C is a negative. 5 over 7, 1 over s plus 7 squared. Okay, so that's done. This is going to be the forced response, right? The 5 from the unit step function, right? The 5 from the unit step function was the forced response portion, so this is going to be the forced. Now we still have to do what's called the inverse Laplace. I'll denote it by this squiggly looking L and a negative 1. That is the inverse Laplace. We have to apply that so that we can get back into the time domain. Because as you can see, we still have s's in our equation, right? But we want to work in time. Right, so I'll leave that for later. I'm going to go ahead and do the partial fraction decomposition for the right side of the expression, or the free response section. So let's go ahead and do that. S plus 17 over s plus 7 squared. I think this should be a little bit faster. This should be pretty quick. So this is going to be decomposed into a over s plus 7 and plus b over s plus 7 squared. So it'll be as plus 7a and just b. Okay, pretty simple. As we can see here, a is the only term with a is with the s term, right? This is the only term, and our only s term is s. So as is equal to s, which means a is equal to 1. Okay. Next, we have 7a plus b. Okay, and this will be equal to the constant term, 17. Okay, so we have, if a is equal to 1, that's 7 plus b. That means b is equal to 10. Let me just check to make sure. Let me just check to make sure that I did this correctly. Sorry about that notification. Yes, I did. Okay. So I'm going to go ahead and delete this. I just need a little bit of room. I'll rewrite this section. So, right, if we rewrite this, it'll be 1 over s plus 7, since a is equal to 1, and b would be just 10 s plus 7 squared. Okay, So I'll go ahead and take this all away, take this all away. Okay. Don't forget that this is actually subtracted, right? So we're gonna go ahead and write parentheses around all that and subtract it. Okay. So I'm gonna work my way from left all the way to the right until we finish this equation, and we're essentially gonna do the inverse Laplace transform to this entire thing. Okay. First up, 1 over s. 1 over s in the Laplace into the time domain actually just disappears, right? If you have a constant times 1 over s, then it just becomes a constant. So first step, 5 over 49. 49 is done. Okay. Negative 5 over 49, 1s plus 7. So if we can see here, s plus 7, 1 over s plus 7 is 1 over s plus a, and the form that takes is e to the negative at. Okay, so the 7 is going to go to the power. We're going to see minus 549 e to the negative 7t. Okay. Next we have 1 over s plus 7 squared, and I know this formula looks a little bit daunting, right? S plus a to some power, right? And this, whoa, lots going on here, right? But n is equal to 2. So let's see what happens when we plug in n equals 2. We're going to get 1 over 2 minus 1, right? That's just 1 over 1 factorial, which is just 1, okay? Now t raised to the 2 minus 1, that is just t, okay? This doesn't matter, right? It's just 1. And then we have e to the negative at, similarly to how we did before, right? 1 over s plus a. So e to the negative 7t, okay? So these components are going to be multiplied by each other. So our final form is going to be, we're working on this guy, so it's going to be minus 5/7 t e to the negative 7t. Okay, and this will be the forced response. Look at that, we answered a part of our question. Okay, next is going to be the free response. Right. So the free response, we should know the form for this one, e to the negative 7t. That one's pretty not too bad, and then plus 10. Okay, plus 10 t e to the negative 7t. All right, and this is going to be the free response down here. Right. And then in order to get these together for the complete, we're going to go ahead and combine all of our like terms. So we can see, let's highlight our like terms. We have the t and e exponentials here, and we have our exponential, just our exponentials here, and then we have one constant term. Okay, so let's go ahead and rewrite that. Now if we have, making sure we distribute this negative, right? So this will be a negative as well. This will be a negative, and this will be a negative. Okay. So we have negative 5 over 7 minus 10. So if we do 7, this becomes 70. We get negative 75 over 7. Okay, so negative 75 over 7, t e to the negative 7t. Okay, these guys are done, right? Negative 5 over 49 e to the negative 7t. So negative 5 over 49 minus 49 over 49. Okay, so this will get us negative 54 over 49. Yeah. Negative 54 over 49 e to the negative 7t. Okay. And then lastly is our constant at the very end, 5 over 49. Okay. That'll be our complete response. And taking a look at my work, that is correct. All right, that was number 2. In part 2 of this video, we'll go ahead and do 3. And in part 3, we're going to go ahead and do question number 4. So hope you enjoyed. See you guys later.